Hey everyone, welcome back to the Jntuh Concepts channel. So in this video we are going to discuss the concept of quantization topic. In that we have subtopics or the subheadings which we need to be covering are discrete energy levels, why quantum, strategic, scientific and technological significance of quantization. So if you are new to this channel, in this channel we cover all the Jntuh subjects which are important for your semester exams that can be conducted in various JNTU universities like JNTUA, JNTUH, JNTUK, etc. So don't forget to subscribe this channel, do like this video, and without any late, let's get into our today's topic. So our today's topic is the concept of quantization. What is meant by quantization? Quantization is a core concept of quantum mechanics that states the certain physical properties of a system such as energy, angular momentum, or electric charge. It can only be discrete values rather than any value in a continuous range. So it is the clear definition of what is meant by quantization. I'll simplify it for you. So quantization states that any physical properties like energy, angular momentum, or electric charge, which in general the quantum systems possess, are usually a discrete or a distinct value rather than a continuous range. So the values of energy, angular momentum in quantum mechanics generally come out as a particular value like 8, 7, 6, 6.5, something like that, but never be in a range like 6 to 7, 7 to 8 in such way. So quantization lies in the heart of quantum mechanics. The earliest evidence of quantization came from the blackbody radiation and photoelectric effect, which were performed by assuming that energy is discrete units called quanta. This is radically different from classical physics, where such quantities are very smoothly considered, but it had inconsistencies to resolve. Then the quantization concept is introduced. Sir Max Planck and Einstein were among the pioneers who proposed that light and energy must be quantized to align with the experimental data. So it is an important point. Quantization is not limited to energy, but also for angular momentum, spin, and even electric charge that can also be quantized. So discrete energy levels. These are specific fixed values of energy that a quantum system can possess as determined by the solutions of the Schrödinger equation. They arise because the wave function must satisfy boundary conditions. Why quantum? Quantum mechanics is not just a theoretical breakthrough. It marks a radical shift in how we understand and interact with the universe of the most fundamental level. Traditional or classical theories fail to explain the behavior of microscopic particles like electrons, protons, etc. Whereas quantum theory helps to fill this particular gap. It fills the gap accurately describing the probabilistic nature of particles. Quantum mechanics form the foundations for transformative advancements in technology, computing, and security. They have improvements in both scientific and real world aspects. So, what is the strategic significance for quantum technologies or quantization? Quantum technologies and mechanics are observed in the increase of strategic value recognized by governments and industries worldwide. Like, example technology can be quantum computing. Quantum computing has potential to break through classical encryption models, etc. Similarly, quantum communications promise ultra secure information transfer using QKD, that is quantum key distribution. Various nations are investing heavily in quantum research to ensure a significant edge in defense, intelligence, cybersecurity, etc. domains. The mastery of quantum technologies is becoming a critical component as a geopolitical power and economic strength for many countries. There are very big players like China, America, etc. They are heavily investing in quantum research and quantum technologies. We'll be discussing such topics in the upcoming videos. So moving to scientific significance. Quantum mechanics is one of the most profound scientific achievements of 20th century. It has revolutionized our understanding of nature. It explains the phenomena which classical physics cannot explain, like superconductivity, quantum tunneling, and behavior of particles in extreme conditions. It enables the modeling of complex systems with high accuracy, leading to discoveries in material science, nanotechnology, fundamental physics. Quantum mechanics continues to challenge our philosophical notions of reality, measurement making it a rich area of ongoing scientific inquiry. Quantum theory allows scientists to model atomic and subatomic systems with a remarkable precision, leading to new materials and deeper insights into the behavior of matter and energy. The quantum technologies or quantization laid a foundation for modern physics and chemistry and technology. So the last subtopic, technological significance. Quantum technology has main theme to bring transformative changes so that to redefine the future of computation, communication, sensing and imaging, etc. Quantum computers can solve certain classes of problems exponentially faster than classical computers, with various potential applications like in drug discovery, optimization, machine learning, climate modeling, etc. Quantum sensors can measure time, magnetic fields, and gravitational forces with a remarkable precision that is very much useful for GPS systems, geopolitical surveys. The other side of quantum cryptography, secure digital infrastructure. All these developments are in early stages and moving towards for the next technological revolution. So this is our today's topic, the concept of quantization and the subtopics. So the summary of this video can be, we have discussed what is meant by quantization. It is a quantum mechanics concept that explains physical properties of systems like energy, angular momentum, can be in discrete values but not in a continuous range. And quantization lies in the heart of quantum mechanics. We have discussed the earliest evidence and who were the pioneers of quantum technologies, why quantum, the technological significance, strategic significance, and scientific significance. All these we have discussed in this video. So that is the concept of quantization in Introduction to Quantum Technologies and Applications, subject of third year first semester in R23 regulation of Jntuh syllabus. So I hope you have understood this concept. So in our next video, we'll be covering the snapshot of quantum technologies like computing, communication and sensing. So that's it for this video. Thanks for watching and keep learning.